Hi, and welcome back to 5 Minute Chemistry with Always Eclectic Stacy. We're so excited to have you. This is our covalent bonding series, and today we're working on molecular geometry using VSEPR and Lewis structures. Here's our 8th example. Let's go. This is the 7th example for VSEPR and Lewis structures using molecular geometry. Today we're looking at CCl₄. Let's remember how to name it. The first element is carbon, so it's only one of them, so we're just going to write carbon. Cl₄, 4 is tetra, so it's going to be tetrachloride. And what we're going to do next is look at the electronegativity. Chlorine's in the halogens. This is going to be more electronegative, so we're going to put that on top. And the electronegativity of chlorine is 3.0. The electronegativity of carbon is going to be 2.5. The difference between this is going to be 0.5, which puts it right on the cusp of polarity. But with the 4 carbons, I'm going to guess this is going to be nonpolar because it's going to go around equally, and then it will kind of cancel out that dipole moment. So remember, carbon has 4 valence electrons, so we're going to go ahead and draw that on our Lewis dot. And chlorine has 7, which means it's always terminal because it can only bond to one thing. So you have 1, 2, 3, 4, 5, 6, 7, right, left, up, down, right, left, up, down. Just like they like for Lewis dot. Remember, that's not the same for Lewis structures. And remember, carbon with the 4 bonds, 4 potentials to bond, can make 4 single, 2 double, a double, 2 single, a triple, and a single. The carbon can only make a single. So we're going to match them up so that it's all the singles. So we're going to go ahead and draw carbon in the middle and connect it to the floor. 4 chlorines. A bit of a tongue twister there. Say that about 5 times and see what I mean. Don't forget to draw in all the valence electrons for chlorine so we can make sure that we're representing all of the electrons in the molecule, or at least the valence electrons in the molecule. And you can see that they're all happy. Chlorine has 8, and each chlorine has 8 and carbon has 8. So now we can go ahead and look for the structure. Remember, we're only looking at carbon. So we have 4 bonding pairs. We have 4 bonding pairs, 1, 2, 3, 4. We don't have any lone pairs on carbon. So this makes it a tetrahedral. So that's the shape, is a tetrahedral. Now, when we're looking at polarity, it should maybe be slightly polar towards a chlorine, but because there's 4 all around, oops, sorry about that, it's going to go ahead and be a nonpolar molecule because there's no place for the dipoles to happen. There's no pull one way or the other. It's pulling all equally on the carbon. So it's going to be kind of equally shared based on the molecular geometry and the fact that there's no place for that dipole moment to happen. Thank you so much for watching. Always Eclectic Stacy. If you like this, please don't forget to like and subscribe.